Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about April 7th this time. That's the week of April 7th. We got a pretty bad moon week. It starts the week about down here. It starts the week about 80% full, and by the end of the week, by the time we get to the weekend, it's filled out. And so on the evening of the 7th into the morning of the 8th, the moon will be about 80% full, and we'll be sitting... it'll be approaching Regulus in Leo, and it will be getting to within about 4 degrees from that star. Remember, fist held out at arm's length is about 10 degrees. So it'll get within about 4 degrees of the star before it gets daylight for me here, something like that. By the 12th and the 13th, we have the full moon, and the full moon will skim right by the bright star Spica. And so you got the bright star Spica there, and the moon will be about 1.5 degrees north of the star. So you watch for the moon this week. It'll be easy to see, big and bright. With the planets, we got Mars. We've been watching Mars. So as it gets dark, you look sort of to the west of the line, that meridian line that passes directly overhead north-south. And to the west, Orion. It's getting to be not the season of Orion. We're starting to lose Orion into the glow of the sunset here. We got time to see it, but there it is off in the west. And above Orion is going to be Taurus. And so Taurus, we see the V of the Hyades, and big bright Jupiter is over there. So Jupiter will be the brightest object in the western part of the sky as it gets dark. And Jupiter is very close to Iota Tauri right now, a 4.6 magnitude star. So you got a good dark sky, you can see it. You might need binoculars if you got a little bit of light pollution, or you're looking into the haze of the western sky there, the atmosphere. The Jupiter starts directly above on the evening of the 7th. Find Jupiter more or less directly over Iota Tauri and moving away from it. So it's within 1 degree to start the weekend, and that opens up space. So that's, if you can find that star and draw yourself sketches, that's going to be something to track. You'll be able to see the motion of Jupiter pretty easily this week. Likewise with Mars. For me, I'm guessing on the evening of the 8th, Mars will be basically in line with Castor and Pollux. So we've looked over here, and we've seen Taurus the Bull. Then we move over to see Gemini and Mars, and we've been tracking Mars there. By the 8th, so Mars starts a little bit, not quite a straight line on the 7th. By the 8th or 9th, it is a straight line. By the 13th, you'll have noticed it's moved all the way over to the eastern side of Castor and Pollux. So you can track the motion of Mars pretty easily this week. That should be fun to do as well. We've been doing that for a long time. So we'll keep that up. Now, to Spica, with the moon near Spica down here, one way we find Spica is we like to say the handle of the Big Dipper has a curve in it. And the curve of the handle of the Big Dipper, we say arcs toward Arcturus, the bright star Arcturus. And then you follow that curved path on down and you get to the bright star Spica. So you can see Spica in Virgo. You go Arcturus in Boetes, and then Spica on down in Virgo. So let's stop. We can't see a lot of faint objects. We can't see a lot of nebulae and a lot of galaxies and stuff like that with the moon as obnoxious as it is this week. So let's stop and look at the stars of Boetes this week. So for me, I do what I do every week, right? I start drawing pictures up there, and I think, well, that's a nice, clean picture. I thought this was one of my better drawings of Boetes here. And then all of a sudden, I've written so much on it, and I've added so many dots and so many notes that you look at it and you're like, what? I don't think that's it. Arcturus is this big bright star in the heart right here. And then we're going to say that, to me, when I see that, you go down to Zeta is a 3.8 magnitude star, and you go over the other direction to Eta is a 2.7 magnitude star. So both bright stars. Should be able to see them okay if you've got reasonably dark skies. That's definitely the brighter star. Easier to see. Myrfid, that's sometimes called. And then, to me, it looks a little bit like a trash bag. As you go up this direction, you come to Rho, and you go up to Gamma, and then the Beta star, and down to Delta, and then to Epsilon, back this direction. So that's your basic pattern of Boetes, a kite. It looks like a kite with a tail on it down here. It looks like a trash bag with tied in a knot right there, sometimes I see. Rho is a 3.6 magnitude star. Gamma is a 3.0 magnitude star. Sagittarius, that's sometimes called Neckar, is the name of the Beta star up here at the top. And I didn't write, that's a 2nd magnitude star. I didn't write that up there. Delta is this star over here, and I didn't write it up there either, so that's a 3rd magnitude star right there. Epsilon down here, Izar, that's called sometimes a 2.4 magnitude star. But let's talk about a few of these stars that are in there. So first of all, just find the pattern, get to know the pattern. Those of you who live as far north, I live 43 degrees north. Those of you who live as far north as I do, this is a familiar constellation. It's up high in the northern sky, and it's up most any night of the year you can find a part of this constellation up. So it's a great constellation to get to know these stars across here. But let's look as we go down here to Zeta. About 6 degrees north of Zeta, maybe 8.5 degrees or so over from Arcturus. So there's a triangle there, and you've got this a little bit farther from Arcturus, but more or less the same distance from Arcturus and up from Zeta. There's a 4.5 magnitude star. So again, not the brightest of stars. Would be easy to see in binoculars. You can see it if you've got good, dark, clear skies. As you go up from Zeta, you pass a little snake bite, a little two prongs of other 4.5 magnitude stars. So you go past that doublet of 4.5 magnitude stars, and you get up to this next 4.5 magnitude star, and that's Psi. And Psi is a binary star that's a good, fun binary star. It's a beautiful object in a small telescope. So you get your small telescope out. Right now, there's about 7 arc seconds that separate the two stars, and so you can see this. We talked about last week how elliptical orbits, and with the elliptical orbits, we talked about the fact that sometimes you see this, it's elongated, and sometimes the two objects are right on top of each other, and sometimes they're widely separated. That's about as widely separated as this pair gets right now. It's got a 150-year period. So it's going to be closing up. It's already past closest to greatest elongation, greatest distance, and it's going to be closing up the distance. So if you want to, we're always looking for these extra long projects for people to work on. If you want a project to work on for the next 30 years, you will be able to see that gap shrink if you just look at it, once a month, once every couple of months over the next 20 or 30 years. That'll be a fun project to track these two stars getting closer together. Arcturus itself, big bright star. It's a 0.1 magnitude star, 5th brightest star in the sky. So Arcturus is the 5th brightest star of all of the stars that we see. It's about 37 light years distance. That's really close. It's not within, there are stars. There are a lot of stars that are closer than that. There's over 100 stars closer than that, but there's 200 billion stars in the galaxy, so that's not a lot of stars on the scale of the entire galaxy. But this is close. But it's also a big bright star. It's a red giant star. That's what makes it being both close and a red giant star. Remember, red giant stars are stars that have main sequence stars. Most of the stars you see are fusing hydrogen into helium in their cores. When that runs out, the core collapses a little bit. It stops producing energy, and that causes it to heat up. And when it heats up, it ignites a shell of material around that core. So you've got this inert helium core, and you've got a shell that's fusing hydrogen into helium around that core. That's a red giant star. That's what's going on. And the star gets brighter, and the surface layer gets cooler. As that hot shell gets closer to the surface, it pushes the surface layer out, and as it expands, it cools. Things that expand cool under the influence of gravity. If they fall inward under the influence of gravity, they heat up. As they expand out, they cool down. So we see a red giant. Red means cool because that surface has been pushed out. It's a giant because the surface has been pushed way out to cool down, and it's emitting a lot of energy because of that hot shell of hydrogen to helium fusion right there. Arcturus is on the red giant branch. What we like to make HR diagrams, we've done this many times before probably, where you have the temperature of the star graphed on this axis increasing that way, and you have how much energy the star is emitting, luminosity, we would say, increasing up that way. Main sequence stars all look like this, high mass stars up here, low mass stars down here. When they leave the main sequence, they go up here to become red giants, cooler and more luminous. And so Arcturus is ascending the red giant branch, we would say up there. So there you go. We got Arcturus to think about, a star that's burned all of the hydrogen into helium in its core. The sun will do that in another 4 billion years, 5 billion years or so. And then it'll ascend the giant branch as well and start fusing hydrogen into helium in a core, and a shell around the core, So we go up this side of our kite, we come to Epsilon, sometimes called Izar. It's a pair of stars, a binary star, a really good binary star system. 3 arc seconds of separation, but that's a challenge because of the brightness distance of the brightness separation of the two stars, 2.5 magnitude, 5 magnitude, something like that. And so one star is a lot fainter. 3 arc seconds, if you've got any turbulence in the atmosphere, that's pretty tricky to see. You probably need a 3, 4, 5 inch diameter telescope in order to pull this apart. You got an 8-inch telescope. You should be able to see that as a really nice pair of stars right there. On up this side of the kite, Delta is also a binary star. And there's a huge separation there, 105 arc seconds. So this is something you could do with a pair of binoculars, except that the secondary star is 7th magnitude, so it's pretty faint. So I'd recommend a small telescope. You might be able to do it with binoculars. A small telescope is going to show the pair pretty nicely. Now, we think of this as a binary system. We talked about a few weeks ago proper motion, how the stars are moving across the sky together relative to other stars, or moving across the sky relative to other stars. But these two stars, the 7th magnitude companion to the bright Delta, they show the same proper motion. They're moving the same direction at the same speed. So we believe those to be associated with one another in space, even if we can't see the orbit like we can with one of these other stars. So that's our stars in Arcturus. Go out and learn the star, Boetius, excuse me. Arcturus is the brightest star. Go out and learn the stars. Think about stars as they evolve. Arcturus is an example of a star that's evolved off the main sequence, and enjoy some of the binary stars in this constellation. I don't think in all the years we've been doing these videos, I'm not sure we've ever spent any time focusing on Boetius. So this is kind of a nice shepherd, kind of a nice break, something new for us to do. Plus you got the planets, you got Mars and Jupiter looking good here. We'll circle back to Venus and maybe even Saturn next week as we start to think about these things making appearances in the morning sky. But that's for next week. We got the moon also this week, and it should be a good week. As always, everybody, thanks for watching.